We have finally reached the point where we can put the two-tier X.509 PKI built in the last chapter to use in order to secure emails according to the so-called signed-then-encrypt approach. The two-tier X.509 PKI we have built consists of a root CA at the top and with two issuing CAs certified by the root CA to issue certificates to end entities. In this PKI, Alice retrieves her certificates from the issuing CA1 and has obtained a certificate for the purpose of creating cryptographic digital signatures. Bob retrieves his certificates from the issuing CA2 and has obtained a certificate for the purpose of encrypting other keys, which is exactly what the sign-then-encrypt approach used to secure emails will require Bob's key to be used for. In this and the following lessons, we will now iteratively add layers of security to the emails exchanged between Alice and Bob, and where the first emails sent will be emails that are neither signed nor encrypted. To investigate the effect of the security layers added to the email communication between Alice and Bob, we will make use of Eve, who sits on the same network as Alice and Bob and is trying to eavesdrop on the email communication by sniffing the network with Wireshark. Once we investigated the insecurity of emails that are neither signed nor encrypted, we will in a first iteration have Alice sign the emails she sends to Bob, and will in a second iteration have Alice sign and encrypt the emails she sends to Bob according to the sign-then-encrypt approach. It will be interesting to see what Eve will manage to eavesdrop in each iteration, and the very last lesson will then demonstrate the effect of a revocation of a certificate involved in the sign-then-encrypt approach. A few words about the setup of the machines involved in this demonstration. All the machines are simple virtual Linux Ubuntu machines set up with VirtualBox and with all the machines part of the same virtual network. In this virtual network, the machine of Alice has IP 192.168.120 and the machine of Bob has IP 192.168.121. For the purpose of exchanging emails, I have installed Thunderbird on both the machines of Alice and Bob, and in order for Eve to eavesdrop on the communication, I have installed Wireshark on the machine of Eve, which will be used to sniff the communication taking place on the virtual network. After the construction of the X.509 PKI outlined in the last chapter, Alice has the root CA certificate and the issuing CA1 certificate available, and of course is in possession of a signing certificate issued by the issuing CA1, and where Alice owns the corresponding private digital signature creation key. Bob, on the other hand, also has the root CA certificate available, but then, of course, the certificate this time of the issuing CA2, and additionally an encryption certificate issued by this issuing CA2, where Bob then also owns the corresponding private decryption key. Having clarified the setup of the machines, it's time to proceed into this lesson's demonstration of what information Eve can eavesdrop on in case Alice sends a completely insecure email to Bob, which then really is just an email that is neither encrypted nor signed. For this, let's have Eve fire up Wireshark, and to start Wireshark monitoring the network communication on the common virtual network, and Wireshark will run continuously for the whole duration of the demonstration in order to not miss out any of the information exchanged on the virtual network. Then it's time to send a plain, unencrypted and unsigned email from Alice to Bob. Having Thunderbird, this is of course a simple matter, which amounts to simply writing an email from Alice to Bob, having the email address bob@example.com. To investigate the effect of the signature and the encryption, I added a subject and a body to the message, and it will be interesting to see which of these elements of an email Eve is capable of accessing when incrementally new security layers will be added to the emails in this and the following lessons. Sending the email then indeed delivers the email to Bob, who at this stage, of course, can read the full email with the subject and body of the email as set by Alice. Switching over to Eve, it's clear from the Wireshark recording that a lot of network activity occurred. Filtering the packets recorded down to just the SMTP packets responsible to transfer emails, it's clear that Eve was indeed capable of seeing that an email was exchanged on the network. The recording shows that multiple SMTP packets were sent, with the SMTP package with number 202 clearly indicating that there was an email sent from a sender with email address alice@example.com and that this email was sent to a recipient with email address bob@example.com as indicated by the SMTP package with number 205. Then the SMTP package with number 213 then indeed contained the plaintext email sent from Alice to Bob, where the subject of the email is clearly visible and listed just at the top of this package, and where also the body of the email is clearly visible and available in plain. This concludes the demonstration of this lesson that emails neither encrypted nor signed are sent as simple plaintext emails across the network, which then makes it fairly easy for anyone with access to the same network to eavesdrop on the communication. This is just the starting point of our investigation on how to secure emails with the X.509 PKI created in the last lesson and the signature and encryption certificates available to Alice and Bob, and it will be interesting to investigate over the course of the next lessons how these artifacts can help to secure the emails such that Eve will no longer be able to eavesdrop.